Hi everyone, welcome back to my videos. I like to do a tutorial in which I solve three problems that I've seen on math competitions for high school students, specifically juniors and seniors in high school. So let's take a look. We have these two rectangles, A, B, C, D, and E, F, G, H. One of the rectangles forms a 40-degree angle with this straight line, and the other rectangle forms a 30-degree angle with that same straight line. And we want to find the value of angle alpha. So if we take a look at these two rectangles, I'm going to denote point O and point P, the common intersection of the two rectangles. So O is going to be the left one and P is going to be the right intersection. So we know the measure of angle C equals the measure of angle E, which is equal to 90 degrees, since A, B, C, D, and E, F, G, H are both rectangles. So 40 degrees plus 90 degrees plus the measure of angle OCE is going to be 180 degrees, right? Because this is a straight angle, so in a straight angle it measures 180 degrees. So if we simplify, we get measure of angle OCE equals 50 degrees. In a similar way, 30 degrees plus 90 degrees plus measure of angle OEC equals 180 degrees, so measure of angle OEC equals 60 degrees. So if we look at this triangle OCE here, we can find the measure of angle COE by substituting what we just found. So we get measure of angle COE equals 70 degrees. Angle COE and angle FOD are congruent because they're both vertical angles, so the measure of angle COE and the measure of angle FOD is 70 degrees. FODP is a quadrilateral, so the sum of the interior angles is going to be 360 degrees. We know the measure of angle F is 90 degrees. We know the measure of angle D is 90 degrees. So if we solve, we get measure of angle FPD right here is equal to 110 degrees. So angle alpha is congruent to angle FPD because they're both vertical angles, so the measure of angle alpha is going to equal the measure of angle FPD, which is 110 degrees. Now let's take a look at problem 2. We're given a regular pentagon is rotated 21 degrees counterclockwise around the midpoint. The figure above represents the first 21 counterclockwise rotation. So we want to find the shape when the hexagon fits the holes next time. So in other words, if we keep doing these 21-degree rotations, what's is it going to look like when this fits into kind of like the black hexagon? So this is an interesting problem. So we know a regular pentagon has 5 interior angles that each measure 108 degrees. Since we rotate 21 degrees counterclockwise around the midpoint, we need to find the least common multiple of 21 and 108 to find the next exact fit. So 21 factors is 3 times 7, and 108 factors is 12 times 9. So the least common multiple of 21 and 108 is going to be 756, which is the same as 108 times 7. So 7's the key number here. So we're going to have to basically move the kind of striped hexagon 7 notches to get to the next point that's going to fit. So if we take point A prime, for example, if we do 5 notches around, it goes back to the original point A. So we have to look at 2 more notches. So point A prime is going to end up at C after doing these 7 the 7 kind of rotations, right? And point C prime is going to go to point E prime here. So if we look at the hexagon, we see that the stripes are parallel to the base, right? C prime, D prime. So in the final position, since C prime is going to land at point E, and D prime is going to land at point A, we're going to see that the hexagon is going to have the stripes that are parallel to the segment AE. So this is one of the answer choices. It was a multiple choice thing. So if we look at segment AE, it looks like this. So the stripes are going to be parallel to that. So that's what the figure is going to look like after we do the rotations. Okay, so problem 3, we're given a prism with 2 triangles and 3 squares. Each of the 6 vertices is matched with a number from 1 to 6. The sum of the numbers around each square is constant. Find the value of x. So this was also a pretty fun problem to solve. So we know that x plus y plus z plus 5, so I denoted these that are vertices as y, t, and z. So we know that if we sum these values in one square, they're going to equal the values in another square. So we can say x plus y plus z plus 5 equals 1 plus y plus t plus z. Now I x'd out in red the common terms on each side, which cancel. So we get x plus 5 equals 1 plus t, and therefore x plus 4 equals t. Now we've already used up 5 and 1 for these vertices, and remember we have to choose numbers between 1 and 6 for the other ones. So the only thing we're left, the numbers that we're left with are 2, 3, 4, and 6. Well, if t equals x plus 4, then the only solution we can get using these numbers is x equals 2 and t is equal to 6, right? Because 2 plus 4 equals 6, and we can't use any other values to kind of satisfy this equation. So in other words, we found what the x value is right here, and the x value is equal to 2. So I hope you enjoyed watching these problems. I hope I explained problem 2. That was a little bit difficult to kind of explain, but I hope you kind of get the idea of what I'm talking about. Problem 1 is okay, it's kind of straightforward. You just have to know how to kind of work around the angles, and this last problem was fun to do. So I hope you enjoyed watching my videos, and I hope to see you in my future tutorials. Alright everyone, have a good night.